Good morning, ladies and gentlemen, boys and girls, friends and neighbors, or good evening, whatever the case may be. So today we're going to start Unit 7, Lesson 2, Angles in XY land, and basically the formal discussion of trigonometry. Thus far, most of our discussions have been based around geometric trigonometric ratios. So we're going to jump into the Trigonometry 101. All the angles we have discussed thus far have been less than or equal to 90 degrees. This is going to be changing in about here in 60 seconds. We certainly have discussed the trigonometric ratios associated with those angles. Those are going to be important. If we consider angles found, here's the difference. If we consider angles found by sweeping a terminal side of an angle around the unit circle, then we can define angles infinitely large. Now, we did look at the unit circle earlier, but we did continue to constrict our angles to less than 90. Well, guess what we're going to do? We're going to take our angles one step further and then take our definitions of trigonometric ratios one step further. And the first thing we need to do is think about these angles, these different angles. And this is going to be hard for some of us. So here's a good definition. We have the terminal side of an angle and initial side of an angle found in the unit circle. The terminal side of the angle is the ray of the angle that sweeps counterclockwise or clockwise around the circle. It is where the ray terminates. The initial side is always the ray with the starting point and origin going in the positive direction. This is always the initial side of all of your angles. And what we're going to do, we're going to take, and we're going to sweep this terminal side. Well, we can sweep it right there. That's an angle. I want to make sure I started at the origin. That's an angle, less than 90, but look what's happening. I can sweep that guy wherever it terminates. That's called the terminal side of that angle. And now we have just created an angle, and this AO, we'll just let this be F, AOF. This angle AOF is larger than 90 degrees. That's different for us because look what we can do. We can take angles. Let me get a different color here. Let me get a funky yellow color of an angle. And I can go, I can sweep that and stop it at any location and get an infinitely large angle. And just keep sweeping it. So let's stop it in quadrant 3. And let's just assume that I went that, so that angle right here, if I just started here and went that angle there, what do you know about that angle? Well, that angle is going to be greater than 180 degrees. Whoa, I've just created an angle greater than 180 degrees. And look what else we can do. And this is just mind-blowing. Never, ever have you ever talked about negative measured angles. Well, guess what? If we sweep that terminal side clockwise, then we are forming negative angles. So let me go a different color here. Let's go blue. And if I can start this bad boy and go negative, and these are negative angles. So that angle right there, that has a negative measure. Whatever that measure is negative. So this is a very important discussion. Certainly easy to see during a video, very hard to see two-dimensionally. Okay? All this review is some of the basic principles from geometry, except for the lowering angles. Similar, to find the measure of the center, the circles are considered now the unit circle, radius 1. The circles, we know that that's the unit circle. We talked about that last week. So, if you recall about circles, we had central angles, and angles were indeed restricted from 0 to 360 degrees. So we talked about central angles of circles, and that's basically what we're doing here. The difference is that, let me move this little guy here. Let me just slide up here. The difference is we can take these angles now and go greater than 360 or greater than 720. When we're talking about geometry, circles in geometry, our central angles were limited from 0 to 360. Okay, so on the unit circle below, so just recall that. And now let's talk about this. On the unit circle below, sketch the terminal side of the angles by simply labeling the end point of the terminal side of the angle. An estimation of the angle is fine. So if I want AOB, this is going to be AOB to be 130 degrees, you tell me when to stop. I want it at 130 degrees. Well, that's going to be 90. That's going to be 180. Well, it's going to be somewhere between 190 and 180. And so that would be 135, so about right there would be about 132, and we're going to label that point right there B. And this angle right here is 132. Now I want AOF 190, so I'm going to change the color of my angle. I'm going to make this time have a red angle, and I want it to stop at 190 degrees. You tell me when to stop. Well, that's going to be 180, the measure of a line, and then whoop, just about 10 degrees more. That is going to be, that angle right there is going to be 190 degrees. Now I want 290 degrees. Let's do a green angle. And we want 290 degrees. So we're going to go 90, 180, 270, about 290. And let's label that rascal right here. You might have to watch this video again. Okay, and this angle right here is 290 degrees. And it might be a good idea for us to put arrows on these so we know which direction and we know the angles are positive. Now we want an AON, angle AON, where the angle is negative. So here's what we're going to do. Let's change our color. Let's go purple. And we want a 90, negative 90. So we're going to start here and go, and that is going to be our negative 90 degree angle. And this point right here would be in. And we know if this is the unit circle, what point that would be. That point is going to be 0, negative 1, because we're always on the unit circle here. And these points, B, F, K, and N, these are defined to be terminal points of each angle because they're the end point of the terminal side. So there's a couple vocabulary words that we need from this lesson. One is initial side of angle, the terminal side. And this is going to be a very important, the terminal point of an angle. And these are the terminal points. It's where the terminal side ends. It's the point that lies on the unit circle. Keep in mind, these are on the unit circle. Terminal points are on the unit circle. So go to the next page of this assignment here. Now here's what's really nice, because we've done this exact thing, and we use these exact definitions. We're just extending the definitions. So the trigonometric values of any angle measure, and this is freaky, no matter how large or how small, can be found by association to the terminal point of the angle. And here's our big definition. Here's our huge definition that we're really going to need to wrap our head around on to understand. Consider the terminal point xy of some angle theta created by sweeping the terminal side around the unit circle, positive or negative, counterclockwise or clockwise. The 6 trigonometric values of an angle can be found by using the following. Oh, the cosine is x, the sine is y, the tangent is y over x. These are the exact same definitions that we did before. If you recall, cosine was adjacent over the hypotenuse. Well, if I'm on the unit circle, the hypotenuse is always 1. So if I'm on the unit circle here, let me go to this unit circle. I have one right here. If I'm on the unit circle, the hypotenuse, all this point right here, is going to be 1, 0. So I'm always on the unit circle. And if I go to this angle right here, here's the terminal point. And we learned that the cosine was the adjacent side. If I jump this down here, was the adjacent side. Well, that's that x value. And that's what they're talking about. So the cosine of this angle, and I'm going to tell you right now, this angle here is 30 degrees. So this hypotenuse is always 1 because on the unit circle. We can find the coordinate of that. And we actually found those coordinates before. And we know from our previous discussion that coordinate right there was square root of 3 over 2, if you remember correctly. And the y value was 1/2. That's the y value, the opposite leg over the hypotenuse. Well, these trigonometric definitions extend it one step further. Because now we can find the cosine of any angle. It's just the x. It's just wherever that terminal point lies on the unit circle, it's that x value. That's the cosine. The sine of an angle, wherever the terminal point of an angle lies on the unit circle, guess what? The sine is the y value. You got to wrap your head around this. The tangent of any angle is going to be the sine over its cosine, which we know, but it's going to be the y over the x. Likewise for the secant, cosecant, cotangent. And there's no use in me repeating these because I want to get to some of these more examples. So here we're going to consider AOH, where the measure of AOH is negative 150 degrees. Well, what have I done? I've taken this angle here. I don't know what color I'm at, purple, and I'm going 150 degrees. So this measure is 150 degrees. And we're going to say it's negative 150 degrees because I've gone clockwise. And we know from previous discussion that this is negative 50. This angle is 30 degrees right there because it's 180 all the way around. And we know that this point is 1, 0. So we already figured out what this point was. Negative square root of 3 over 2, negative 1/2. We know what that coordinate is from a previous discussion. Now we can find the sine of negative 150. What is it? Oh, it's that y value, negative 1/2. What's the cosine of negative 150? Oh, it's that x value, negative square root of 3 over 2. What's the tangent? the tangent is still going to be the opposite over adjacent. The opposite is going to be the y, so it's going to be negative square root of 3 over, 1/2. It's going to be negative 1/2 over negative square root of 3 over 2, and that simplifies to 1 over square root of 3. Multiply that bad boy by square root of 3 over square root of 3, and you get square root of 3 over 3. And that's the tangent of negative 50. Okay, so now let's go example number 2 using the same unit circle, same circle. Find the label, the measure of AOK, where the measure of AOK is 135. So let's go 135 degrees. Here we go. Let's do a blue terminal ray. Start here and go to 135. Right there, 135. I want 135. Bam. This guy right here is going to be K. And this angle here is going to be 135 degrees. Well, what is 135? 90 plus 45. So this small angle here, which we found already, we found the points of that on the unit circle. And the points were negative square root of 2 over 2, square root of 2 over 2. So the coordinates of this is negative square root of 2 over 2, square root of 2 over 2. And you'll have to go back and look at your notes from the last 2 weeks probably, that we've done all this. Now we're just connecting, making all these connections. And so let's find the following with no calculator. Use simplified radicals. Well, what is the sine of 135? The sine of 135 is the y. This is what you need to remember. If I'm going to jump up here to the top of these notes, this is what you need to remember. The cosine is the x, the sine is the y, the tangent is the y over the x. The secant is 1 over x, cosecant is 1 over y, cotangent is x over y. Or 1 over cosine, 1 over sine, cosine over sine. Because we are definitely going to need to know these other 3 trigonometric ratios. But it's the foundation is that the cosine of an angle is x and the sine of an angle is y. And the tangent of an angle is y over x. That's the foundation. So I can find now what is the sine of 135. Oh, it's the y value, square root of 2 over 2. The cosine is the x value, negative square root of 2 over 2. And the tangent is the y over the x. So it's going to be square root of 2 over 2 over negative square root of 2 over 2. That's the tangent. Whoa, whoa, whoa. Negative 1. Negative 1. So there's a lot going on in this lesson, certainly a lot going on in this lesson. You might have to read this lesson a couple times. This is an extremely important lesson for success in pre-calculus. Let me zoom out here to get, that's too much. Let me go to the entire page here. So there's your page, your first page of notes, your second page of notes. You can take and reread this. This is in your interactive text. Get it filled in and get to studying this. This is extremely important. I will see you soon.